Hello everyone, this is a presentation on the quicksort algorithm. Uh, this will cover the purpose of the algorithm, how the algorithm works, and that's a typo, should be the big O, performance of the algorithm. The purpose of the algorithm, you know, so what is quicksort, why is it used, the common applications. Quicksort is a highly efficient sorting algorithm that uses a divide and conquer uh, strategy. Uh, Quicksort is a highly effective sorting algorithm developed by Tony. I can't pronounce his last name. Hoare in 1960. It's used to sort elements of an array or a list based on the divide and conquer strategy. Uh, the divide and conquer falls into it choosing a pivot of which it will organize everything to the right or left of. Everything that is smaller than the pivot goes to the left, smaller equal to, and everything that is larger than the pivot goes to the right. And then it moves through the array in that way. Quicksort is widely used because it's of efficiency and simplicity in implementation, making it a popular choice um, for database query optimization, searching algorithms, and many other things. Uh, as I mentioned, how the algorithm works, explaining quicksort process. It chooses a pivot. It separates everything into two subarrays, and then recursively calls the quicksort and it recursively applies the sort function to organize everything based on where on the pivot, uh, moving through the array until everything is in its proper order. Um, from however you would like to order it. In the case of numbers, just say like lowest to highest. Um, Supposing you have a list of numbers or an array, let's say everything from 1 to 10 jumbled up, and you need to arrange them. What it'll do is it'll choose a number depending on how you have it. You can do it randomly, but it will choose a pivot and it will take um, the numbers to the right and left of it and choose if it's higher or lower. And if it's lower or equal to, it'll move it to the left. If it's higher, it'll move it to the right. Um, and then recursively go through it again, choosing the right and left, moving farther down until everything is in the right order and everything's in the place that it needs to be um, through the two subarrays. Uh, the process has three main steps. One, choosing the pivot of the mission, partitioning the array or breaking it up into the separation, and then recursively applying quicksort into the subarrays, then organizing them um, and laying everything where it needs to be. The performance of the algorithm in the best case and average case is in log n. Worst case is n squared. Um, the best case occurs when the pivot divides the array into two equally sized halves. The average complexity is also, as I mentioned, O of n log n, um, which is it still follows on the same line of the best case. And then the worst case, um, when the smallest or largest is chosen as the pivot, the time complexity is n squared. Despite the worst case scenario, quicksort is generally faster in practice compared to other O of n log n algorithms, much like merge sort due to its low overhead. Uh, and the problem with the short is that not only does it, because with the worst case scenario, you have the largest number, um, and then it will move through. It has to move through the entire list because it can't split into two lists because there's nothing higher and there's or if you have the lowest, there's nothing lower. So it has to go through the entire list um, as the low at the low end and just recursively going through that time and time and time and time and time again, which is why it's n to the power of two. Um, an implementation. Um, so I don't think that I made it. Uh, sorry, totally. A quick walkthrough of the code and everything that it has. Uh, we see that in with C sharp, um, this is the assignment uh, that I built out for the class. Uh, it's only what 82 lines, and that includes comments, which means that it's more like 30 if you break it down or so. Um, and let's look. Uh, so we'll start here with this because up here you have namespace algorithm lib. That's just where it is. Um, and this is naming the class or you know what we're doing here. Uh, public static void sort. This is the one that will be well. I guess this is recursively called the underscore, and this just calls the static sort underneath it. Um, this line has the recursion start when it calls the underscore sort method, uh, starting the index at 0 and ending the index at data count -1, which is at the very end of the list. Um, then we have the underscore sort. Um, it takes again the last, the first, and the data, which is a list um, built out. It starts out comparing um, the first and the last. And if the first is greater than or equal to, or less than or equal to last, it'll just return it. Uh, and this is where it's making the pivot. Uh, it calls partition. It calls the partition method to partition the list and returns the index of the pivot point. The following lines are the recursive call for the underscore sort and for the sublists that are made. And if um, we're dealing with the first, it will make the pivot -1, last pivot +1. Uh, partition, which we see is called up here. Uh, so the LMGP is the starting point that it goes through. It stands for last move greater position, uh, which is why it's equal to first, meaning that it's the first location um, that it will start comparing to. We have the for loop, which shows that the index is equal to first, and if the index is, oh yeah, I guess that was greater to up here. I'm sorry, but if the index is less than last, the index is increased. Um, if uh, the if statement checks if the current element is less than or equal to the pivot element, um, which is the last element, as we see. Wait, just as we see here. That's what I was after here. Meaning that if it is less than or equal to 0, then it'll do what it needs to do. Um, this swaps the current element with the element of LMGP, making the LMGP the current element. Um, this swaps the, yeah, and this increments the LMGP index, meaning that it goes through the next step, increasing it to the next location of the in the list. Uh, then after the loop, it swaps the pivot element with the element of LMGP index, placing the pivot into the correct sorted position. The method then returns the LMGP index, which is the new pivot index. Um, Basically, this code implements the quicksort algorithm using static class, using a static class, which generic methods and sort the list into the elements that is compared to. The main method sort indicates the sorting process, while the underscore sort method handles the recursive sorting, and the partition method partitions the list around the pivot point, separating everything and organizing the way it needs to be. I think that's everything that was needed to cover.